All right, number 2, we're going to do the same as number 1. We're going to use the rational zero theorem to find all the possible zeros, and then we're going to try to find them. All right, so this problem is at a t of x. T is equal to x to the 4th minus 6x to the 3rd plus 4x squared plus 24x minus 32. All right, so again, the process is you're going to take the constant term and divide by the coefficient. And we're going to find all the factors. So we have 32 over 1, and everything is going to be positive or negative. I'm going to list all the factors of 32. 1, 2, 4, 1 and 32, 2 and 16, 4 and 8, and that should be it. And then on the bottom, the only factor of 1 is just 1. So my completed list, positive or negative, 1, 2, 4, 8, 16, 32. Okay, so our polynomial 4, 3, 2, 1, 0, we're not missing any terms. We're just going to start with 1. We're going to work our way up. I'm going to start with 1, put 1 in the box. So this is if you didn't have a calculator and you don't know which of these numbers work. We're just going to guess and check. I'm going to start with the number 1. I'm going to list all my coefficients. 1, negative 6, 4, 24, negative 32. This is where it'd be better to have a pencil and eraser, so you can just erase and then change that number. But with a pen, I'm going to have to rewrite the whole list again, over and over again, until I find a couple numbers that work. So I'm going to bring my 1 straight down. 1 times 1 is 1. Combine, I get a negative 5. 1 times negative 5, combine, I get a negative 1. 1 times negative 1, combine, I get positive 23. 1 times 23 is 23, combine, and we get a negative 9. So that does not end in a 0. So 1 is not a 0. So then I would have to try maybe 2. And we'll do 1, negative 6, 4, 24, negative 32. Bring my first term straight down. 2 times 1 is 2. Combine, negative 4. 2 times negative 4, negative 8. Combine, negative 4. 2 times negative 4, negative 8. Combine, and we get a positive 16. 2 times 16 is 32. Combine, we get 0. Okay, so now we have found a 0, so 2 works. X equals 2 is a 0. Now, I don't know if 2 is a double root. So once you find a 0, you don't have to keep starting over. Okay, you can continue from where you are. So this is a x cubed now. I'll just keep myself reminded of that. We start out with the 4th degree, and once we drop it 1, it's now x cubed. I want to try 2 again. I don't know if it's a double root, but I want to try to make sure it doesn't work before I move on to one of these other numbers. So I'm going to try 2 again. And then if I conclude it's not a double root, then I'll move on to another number, and I can just continue from here. So I'm going to start here, bring down 1. 2 times 1 is 2, combine negative 2. 2 times negative 2, negative 4, combine negative 8. And then 2 times negative 8, negative 16, and then we get 0. So look at there. It worked again. So x equals 2 is just a double root. You don't have to list that number twice, but it is a double root, and it has helped us now get to a point to where we can solve it. So this was an x cubed. Drop it down another degree. This is x squared. So from here, I can now solve this polynomial. X squared minus 2x minus 8. And I'm going to see if this will factor. 1 times 8 is 8. Factors of 8 are 1 and 8, 2 and 4. And we want to subtract to get 2. These two will subtract and give me 2. So it looks like 2 may be a triple root. So this will factor. No, it'll be a negative 2. X here, X here. The numbers we use 2 and 4. The bigger sign is the first sign. And then this tells me they're different. So these are my two factors. If I set them equal to 0, we get x equals negative 2. And then over here we get x equals 4. So here are my other zeros. Negative 2, 4, and positive 2 are all my zeros. So this one worked out really nice. I didn't have to do a whole lot. But a lot of times it may not be so nice. Like you might have to go through 4 or 5 numbers before you actually find one that works. So first, let me go back. We're going to list the possible zeros. 1, 2, 4, 8, 16, and 32. And then we're going to list the ones that actually work. So 2, negative 2, and positive 4. So those are the numbers we did when we got synthetic division.